Alright, just back with this thing. I'm going to say that I actually did get it to work. So I spent quite a while after I finished the last video going, oh, why doesn't it work? Why doesn't it work? And fiddling around and carefully going through and doing all the wires. I'd made a few modifications, but I'll just turn it on, and this is what it does. So it goes up and then it goes down and it disappears for a while. So I'll talk about that in a second, but I think it's quite therapeutic. I was going to add, maybe I can do that now. Sorry, you kind of need to make it so that you could adjust the rate at which it works. And I could use, I haven't written on these things, a variable capacitor. This is 503. Well, that could work. We'll do that in a second, those ones. Sorry, I've still got a cold and I'm still coughing a lot. And I fell off my bicycle yesterday. So that wasn't too. It's the second time this year, and it was quite painful. My leg hurts today. But so what I had to do, the main problem was, as I mentioned last time, is that the inputs and the outputs. So the output can only go to within 1.3 volt, 1.5 volts of the supply voltage, so the LM324s. And also, you shouldn't be supplying it. It doesn't work very well if you're supplying into one of the inputs of the op amps if you're supplying more than that voltage. So I had to fiddle around with this voltage divider thing here that I've got going. So there's quite a few little resistors. It makes quite a few steps here. But this is the top bit here. So what I ended up doing, and there's a much better way of doing this, but I just hacked it in for now, is I just put two diodes in here. That gives a voltage drop of, so we can actually see it, a voltage drop of about, what was it going to say? Oh, it's only going to be a voltage drop of about 0.8. But by the time I get down to the test point, the maximum test point, the cutoff point where I flip to go down, I should do it the other way around. We still aren't quite there, so I need to work on this. Oh no, it says 3.43 is the voltage for which I flip the flip-flop and start discharging the capacitor, which is just within the limits, right? So it works now, but you have to work out a better way of doing it. So I'd have to, the best way of you don't need the diodes at all. So I'm sure if I had a much bigger resistor here on the top end of the ladder, sorry, then I would be able to, it should work better. But at the moment I'm just stuck with the 33K that I had before, and we're all going with that. But it does work fine, and I'm quite happy with that actually. I feel quite chuffed that it's doing this. It does. I'm not entirely sure why it acts exactly the way that it does. That's the circuit that we tried to do. So it does roughly work the way. There's an ant on this thing. So that's nice, because I was really worried that after a while I was like, oh, this isn't going to work at all, is it? But I wanted to do this partly because I think it's very similar to the way that the basics of how a 555 timer works. Except in that one you're not doing any LEDs. This is not a very good night to be doing this. But it's actually just using three 5K resistors, and then you're measuring it between 1/3 the voltage and 2/3 the voltage, the supply voltage. I'm going to go through and attempt to make a 555 timer out of things like LM324s and 4011s. I might use different. It's not very good today, is it? The other thing is I changed the where did I put my drink? I changed the, so before I had the lower limit, resistor here, so I wanted this to be quite low, so I wanted it to go all the way down to the bottom. So remember, when the voltage drops below this point here, the last LED goes out, so that's that phase at the very end. And then when it goes below here, then you want it to flip to start charging back up the capacitor and going back the other way. And so what I had before was a 470 ohm one, but in comparison to all of this, that sort of produced a very low voltage there. In fact, according to this thing, it was 0 volts. So whatever it was, it didn't really work too well, so I had to bump it up to 5k, and then it works okay. The only thing about it is that it has that sort of thing where it goes up to it lights all up, and then it goes down, and it goes out for a little while. It sort of slows down, which is what you expect. So this is my picture of discharging and recharging of a capacitor. So the voltage, this is the voltage going this way, and this is time going that way. I should have written that in, I guess. Hold on. Time and B. So I'm only guessing is that what happens is, so this is the point, this is the voltage that causes the last LED to turn off, and then you're kind of like on the long tail. Like I'm guessing that's, well, it's because it's just the way I've all arranged it. If I sat down and thought out the numbers better, maybe I could get it to work, but I kind of feel like it should not have such a long pause when it's off, and it has a very brief moment when it's at the when the green light turns on. So that could also be fixed. I mean, maybe I could just fix that. If I do that, hold on. So it's it kind of works. It's not really changing it. So, well, that's actually kind of interesting. So when I take this off, the voltage reference is floating for the green one, and so it does eventually go down. So is there any way of stopping it? Oh, yeah, if I hold on to it, it takes longer. I wonder what it's actually reading off this. So this is the voltage it's comparing it to, but there's nothing actually plugged in at the moment. So it doesn't really matter. I like the effect, so that's all I really care about. And it works. It oscillates and it works and it's fun. Ultimately, I think if I was going to make this, which I think I will make it into a little, I'll solder it all up and make something out of it. But what I was thinking would be is that you would just have 2 LEDs per light per output instead of one. So put them up to some transistors, and then use that to light up the LEDs. Because then you could have them going out this way, so the pattern would start out and then go back in, start out and then go back in, and maybe have it in like a circular shape, and then it would go up and down, up and down. I think it'd be quite pretty. So that's quite a neat thing for not using any microcontrollers or anything. This made me happy, but I would like to, I'm going to come back to this project at a later point, and try and do it without using the 4011 and just use the LM324s, because I think I can do that. I think maybe it will work. I'll have to think about it for a bit. So that's just one thing. I just want to see it if. So this resistor here is the one that's changing, in theory, the rate at which it charges up. So I'm going to change that slightly. Where did I put that? Oh. Where did I put that? Sorry, we're just going to use this one. So you've got to have at least a resistor in the way. So I'm going to turn it off for a second because I want the suspense to be built up. I'm going to take that one out. I'm going to turn this thing off. And I'm going to put in this. So there's a 120. So it's a very low resistance. And I'm going to get one of these. So 503 I assume means it goes up to 50k. So we should be able to get it slightly slower, but also much faster. So I'm assuming that the lower the resistance, the faster it charges up and the faster it goes. So this will be interesting. And the good thing about this, and is that, so the problem is, of course, is that there's 2 inputs to each op amp, the inverting and the non-inverting one. And the non-inverting one usually is going to be coming from here, I think. This is where I get them all confused. Here's this one. So sorry, the non-inverting one is the test voltage, that's right, and the inverting one is the reference voltage. But you also don't have to worry, like, it will only ever go up pretty much to whatever this one is. So if I've got the correct voltage on the non-inverting input, then the inverting input is never going to go too high either, because it's restricted. Because as soon as this thing crosses the boundary of this thing, so as soon as the voltage across the capacitor gets to the point where it crosses the boundary from this voltage divider, then it will start discharging. So it won't ever go any higher. So you won't get like 5 volts going in. So you don't have to worry about that. So I think that's gone in. Has it gone in the things? Alright. So let's just turn this. I need a screwdriver. And believe it or not, I don't know how this happens. I've got a bulky big screwdriver. This is not the right screwdriver. Or does it work? Yeah, I can turn it. So let's just finish it up by seeing what happens now. So can I make it go faster? I can. Look at that. It's zooming along. Now it's going so fast that you can't really see it, which is quite cool, because you would think that this would dim them. It doesn't really do it. Like, I was kind of hoping that you'd see that this light would be a lot dimmer, a lot brighter than the rest of them, because this one's on most of the time, and this one's on very rarely, but it's still quite bright. So maybe we can turn it down a little bit. There doesn't seem to be much in the way. So maybe that's just charging up too fast for the capacitor, for the LM324 to cope with. I don't know. But because you can't quite seem to get, it just seems to do that. Now you can kind of see that it's actually doing it. Otherwise it just seems like it's flashing on and off. So then we can go real slow. The green one always only comes on with this. Oh no, that's a bit longer than usual. So yeah, I just have to think out that voltage divider a bit better. So that's the slowest we can get it with the 503 variable potentiometer thing. So I hope that was interesting. I thought it was fun, and I'm glad that it worked. And I really need to edit videos instead of making 3 videos and 2 where I don't get very far. But thanks for watching, and hopefully soon I will be better. We're going to go. The next thing I want to do is go back to the Pong game, and then we're going to try and do some fun with more joystick fun and retro computers. So I want to get into doing that. So that's going to come up real soon. And maybe I'll have a video about fun with capacitors just in general. So thanks for watching. Like, share, and subscribe. I mean, nobody actually watches these videos, but in the future, if you like this and you want to build it yourself, just make a comment, and then I will make up a schematic or something of it. But I think it's more fun if you try and just build it yourself, because otherwise it's kind of like, well, it's not really a very useful circuit, is it? Except for making pretty pictures or pretty patterns. So thanks for watching. Bye.